As mobile customers worldwide flock to the latest handsets and applications, data is taking on more and more importance. And not just on the front end where customers usually think of 3G and 4G and handset speeds, but the backhaul as well. And we're here today to talk with Patrick Donegan about what's going on in mobile backhaul. Patrick, there have been some challenges in commercializing the 1588 standard. What have they been?
Well, what you have to bear in mind is that when the standard was first implemented, it was on Ethernet backhaul networks, which in their nature back then were quite immature. And as those implementations have matured, so it's become easier for the 1588 standard to perform well on it. There have been a number of other factors that have improved the performance significantly. The obvious one is the introduction of the telecom profile, which has made the standard more optimized for telecom implementations. But there are some other commercial issues as well. The standard is now baked into silicon, which vendors can now just buy off the shelf, which is extremely important. And some of the vendor interoperability and conformance efforts have really gathered momentum in the last few years. So from being very tough to implement, it's getting a lot easier, and we're well on the path to it being a sort of plug-and-play standard.
And what advantages does 1588 v2 have over other synchronization standards?
Well, the key one is that per the ITU's roadmap that it's developed is that 1588 v2 now supports a roadmap for frequency, time, and phase synchronization, which is a roadmap, for example, that the synchronous Ethernet standard doesn't have. That's a key issue. So as operators roll out various features in the future, as they roll out LTE in FDD and TDD mode, 1588 v2 potentially supports all the various types of synchronization that an operator might want.
So Patrick, where operators already have a standard, such as GPS, deployed at the cell site, why should they deploy another standard?
Well, you have to consider, first of all, that GPS itself isn't entirely fail-safe any more than any other technology is, I don't suppose. Consider also that a number of countries are wary of being entirely reliant on a technology that is owned by the US. And you also have to consider other things, for example. When you move to a small cell environment and you go to many more smaller cells that are in building, for example, you're not going to be able to get a GPS signal into a receiver in that particular environment, so you're going to require another synchronization standard such as 1588 for those kinds of examples. What we're seeing increasingly is the sort of any two will do philosophy, which is that as operators evolve to Ethernet backhaul, they recognize that they're going to need perhaps two standards to back one another up in a complementary way to support different types of applications.
Thank you for being with us today, Patrick.